So, good day everyone. Our topic for today is about test of hypothesis. So, in this lesson, no, you can identify population parameters. It can illustrate null and alternative hypothesis, level of significance, critical region, and types of errors in testing hypothesis. Identifies appropriate test statistics when a parameter is known, unknown, and using central limit theorem, formulate appropriate null and alternative hypothesis, compute critical values, construct or sketch the critical and acceptance region, draw conclusion about the population based on the test statistics in rejection region, and solve real-world problems. So, this module discusses about some key concept of test of hypothesis. It includes the null and alternative hypothesis, level of significance, rejection region, in the types of errors and hypothesis testing. There are activities following every discussion which were designed to test your understanding about the discussion. We need to take note that hypothesis testing is a decision-making process of evaluating claims about a population based on the characteristic of a sample from the population. It decides whether to reject or accept the null hypothesis, and some uses the following decisions. The null hypothesis is rejected or failed to reject the null hypothesis. Acceptance implies null hypothesis is true. Failure to reject implies that the data are not sufficient enough to reject the null hypothesis. In this discussion, your decision either reject the null hypothesis or the data are not sufficient enough to reject the null hypothesis. So, testing hypothesis follows the following steps. Formulate the null and alternative hypothesis. Select the level of significance in the test type. Determine test statistics to be used. Compute the test statistics and critical values. Construct acceptance, rejection regions. And make a decision or draw a conclusion based on the steps 4 and 5. Then, the interpretation. Now, when we say null, it was defined as having no value or amounting to nothing. In statistics, hypothesis and assumption or conjecture about a population parameter which may or not be true. In the scientific method, the hypothesis is constructed before any applicable research has been done. The null hypothesis is a statement denoted by the states that there is no difference, no changes, nothing happened, no relationship between a parameter and a specific value, or the independent variable has no effect on the dependent variable. It makes a statement about the population, not the sample. The true value of the population parameter is specified in writing the null hypothesis. In symbol, it is written using the following format. So, as what we have here, is for null hypothesis, H sub O. This will be the population parameter, the equality symbol, and of course, the value of a population parameter. Now, the alternative hypothesis. It is the statement denoted by is a statement that states that there is a difference. Denoted by h sub 1, of course. No? An effect-change relationship between a parameter and a specific value, the independent variable has an effect of the dependent variable or something happen. An alternative hypothesis is a statement that directly contradicts a null hypothesis by stating that the actual value of a population parameter is less than, greater than, or not equal to the value stated in the null hypothesis. So, this will be the alternative hypothesis. Will also determine the type of hypothesis testing will be conducted. So, as what we have here, we have what we called one-tailed test. Will be used when using OR, of course. Two-tailed test will be using when is used. So, here is the common phrases used in hypothesis testing that will guide you the correct symbol to be used in formulating alternative hypothesis. So, we have here the greater than, the less than, the not equal, and of course equal to. How about the level of significance? Of course, significance is defined as the quality of being statistically significant. No? The level of significance, or sometimes significance level, refers to a criterion of judgment upon which a decision is made regarding, of course, the value stated in a null hypothesis. Its value is between 0 to 1 or between 0% to 100%. The level of significance denoted by Greek letter alpha A is a probability of rejecting a true null hypothesis. In public health research, alpha is using 0.01 or 1%. In social science, alpha is usually 0.5% or 0.05 or 5%, and 0.10 or 10% in other studies. So take note, if you are in the allied health, most commonly using 0.1 because of course that is life, right? So that is just only 0.1 level of significance. For social science, that is 0.05 or 5%. In other studies, for ICT, for human HRM, and so on, or HRO, that is 10%. But most commonly, we are using 0.5. This implies that there is 1%, 5%, or 10% probability of rejecting a true null hypothesis. Further, it implies that the result has 99%, 95%, or 90% chance of being true, respectively. And of course, in symbol, it written as follows. No? So, 0.01, no? Null hypothesis or level of significance, that is 0.01, 0.5, or 0.10. Furthermore, if the alternative hypothesis used not equal, then alpha will be divided by 2. So, alpha of course sub 2 is 0.005, 0.0025, or 0.05. How about the criterion or critical region? It is also known as rejection region, a range of values that correspond to the rejection of the null hypothesis. If the value of the test statistics is within the critical region, then the null hypothesis is rejected. Otherwise, the null hypothesis is not rejected. And this will be based on the alternative hypothesis. The critical values of the test of hypothesis are the number or numbers that determine the rejection region. Thus, critical region might be a single number or an interval. For one-tailed test or directional set or directional test or less than, no, the critical region is at the left side of the acceptance region. For one-tailed test or directional test greater than, the critical region is at the right side of the acceptance region. For two-tailed test, the critical region is both at the left and right side of the acceptance region based on what we have here, no? Based on the given diagram, we have here the critical region, the acceptance region. So this time, for this one, that is less than, no? That is acceptance is in the left, then critical region at the right for less than, okay? Then for not equal, as you can see here, so both side, left and right, of the acceptance region. Let's say, for example, suppose that a normal distributed population has a standard deviation of 0.12. Given a sample size of n is equal to 10, and null hypothesis is 10 and h sub 1 and h sub 0, and h sub 1 is greater than 10, or yeah. Construct the rejection region if our level of significance is equal to 0.05. So based on the given at, so we are here the formula. No. Then we could able to get 0.03794. So notice that h sub 1 greater than 10, this is one directional test using the standard normal table. So therefore, the critical value is equal to 10.0624. The critical region is illustrated on this page, no? It is the darkened area right side of 10.0624. Another example, suppose that a normal distributed population has a standard deviation of 0.12, given a sample size of 10, while null hypothesis is equal to 7 and alternative hypothesis is not equal to 7. Construct the rejection region if level of significance is 10%. So, of course, direct substitution. So, therefore, we can get 0.3749. Then, the total test using standard normal table, that is 1.645. Then, the critical value is computed in this way as what we have here. Okay? So, 7 multiplied by 1.64, multiplied by 0.038. That is 7 minus 0.6424. Therefore, that is 6.9376. The other way around, for the critical value of this one, that is 7.0624. The critical value is illustrated here. Okay, so which is 7, 7.624, and 6.9376. The type of errors in hypothesis testing. Type 1 error is committed when rejecting a true null hypothesis. The probability of committing it is denoted by, of course, the alpha of the level of significance, or the level of significance. While the type 2 error is committed when accepting a false null hypothesis. The probability of committing it denoted by this symbol. Okay, this will be the probability of committing, or denoted by this given symbol for type 2 error. So, again, this will be the commonly used level of significance and its corresponding critical values. We have here the given level of significance at the left side, of course. So that is still 0.05, 0.1, and 0.001. We have here the test type. So for 0.05, it must be within 1.645 or negative 164.45. O for 0.01, that is 2.33 or negative 2.33. For 0.001, that is 3.09 or negative 3.09. For two-tailed, okay, that is positive or negative 196, and so on and so forth. Okay, before we proceed to the next lesson, no, I just want to reiterate once again on our lesson 1. Hypothesis testing is a process in making decisions and evaluating a claim about the population having on the characteristic of a sample from the same population. Null hypothesis is a claim about the population which state no difference, no changes, or no relationship between or among variables. Alternative hypothesis is a claim about the population which state differences, changes, relationship between or among variables. When we say level of significance is the probability of committing type 1 error, then the critical region, also known as rejection region, is a range of values that corresponds to the rejection of the null hypothesis. Type 1 error is an error committed when rejecting a true null hypothesis. Then the type 2 error is an error committed when accepting a false null hypothesis. Now, so of course, we need to take our references for lesson 1, that is Alferez Duro from MSA Statistics and Probability, of course. Average construction worker, play in the Philippines. Basic concept methodology for health and sciences. Bilicina, of course, statistics and probability. Berman, retrieved May 27 from StatTrek. Pareño, of course, and Jimenez, basic statistics. An introduction to hypothesis testing reviewed. Merriam-Webster Online Dictionary. Minitab Express support. Now, we will proceed to lesson 2, exploring testing hypothesis. After learning some basic concept involved in hypothesis testing, you are now ready to learn the parameters involved in the process. So it is very important because this will guide you on selecting the appropriate steps and formula to be used during the test. Now, real-life problems will be given and be used to determine the parameter to be tested. So, parameter is a number that summarizes some aspect of the population as a whole. Okay, so example are population mean and population variance. Statistics is a value computed from the samples. And example are sample mean and sample variance. So hypothesis is a claim about the parameter like the population mean or the population proportion. So we have z-test on the comparison between the population mean and sample mean. When do we use the z-test? Z-test used for the comparison between the population mean and the sample mean. Okay? Decision making is part of our daily lives. We are given different options. This situation is the same as in testing hypothesis. Option can be treated as hypothesis. It is like the process of selecting which of this option is best solution to our problem. There are steps to follow to come up with the solution. The first step in hypothesis testing is the formulation of the null and alternative hypothesis. The z-test on the comparison between the population mean and sample mean is used when the population mean and the population standard deviation are known. Again, when do we use the z-test? Comparison between the population mean and sample mean. And it is used when the population mean and the population standard deviation are known and is compared to a sample mean. It is also important to identify the parameters or statistics involved in the problem to determine the appropriate formula. So we have here a given example. So if your study, synonymously the same with this example, so therefore, this will be the way on how you'll be able to get your, or to compute your z-tests. So we have a given sample size, population mean is also given, no? The population standard deviation is given. The sample mean is 5 actually. Then, we have here to test the null hypothesis and alternative hypothesis. H sub 1 that is null hypothesis. H sub 0 that is null hypothesis. H sub 1 that is alternative hypothesis. Okay? So, and that's it. Example number 2. This one is about face mask, right? And we have a sample size of n. Population mean is equal to 10. Population standard deviation is 3. The sample mean is equal to 4. So, formulation of null and alternative hypothesis. It's too easy actually if you have a problem already, no? Then example 2.143. This one, conducted teacher a study to know if blended learning affects the student's performance. So, the sample size, of course, is 30, no? And so on and so forth. So, of course, you need to, again, to formulate your null and alternative hypothesis. Now, t-test on the comparison between the population mean and sample mean. Again, this time, t-test if we compared the population mean and the sample mean. So, this test will be used when the population standard deviation is unknown. Take note, this t-test will be used when the population standard deviation is unknown, but the sample standard deviation is known or can be computed. The t-test will replace z-test, and the degrees of freedom or DF is the number of pieces of independent information available for computing variability. The required number of degrees of freedom varies depending on the size of the distribution. For a single group of population and for two groups for t-test, where and are the population size. So, here's the example. So, this time, that is population mean and sample mean. Okay? So, that is for t-test. Then, we define the formulation of null and alternative hypothesis. Sample number 2.3. So, this will be the Rural Health Unit conducted survey on the heights of the male aged 18 to 24 years old. So, we have the sample size, we have the population mean, we have the sample mean, sample standard deviation. Then, you may formulate a null and alternative hypothesis. Okay, this time, before we may proceed to this lesson, no? So, what we learn from the previous lesson, or lesson number 3, or number 2 rather. The parameter present in hypothesis testing problem will guide us in choosing appropriate type of test. Again, parameter is a value computed using the entire data of population, while statistics is a value computed from a sample. When both parameter and samples were given, the use of parameter will prevail. In formulating alternative hypothesis, be mindful of the keywords for inequality or the keywords for not equal. So, statistics value usually mentioned together with the sample size of a sample. Okay, so this time, that lesson number 3. The test statistics and rejection region in hypothesis testing. Now, we are always heard the term rejection region. This lesson is a continuation on the steps in hypothesis testing, and you will learn here when to use the different test statistics and the possible position of the rejection region. It will be easy because you have learned some illustration and description of these terms in the previous lesson. So, test statistics are value computed from the data. The test statistic is used to assess the evidence in rejecting or accepting the null hypothesis. Actually, in some common, no, especially during defense, no, the panel are always asking about the evidence of rejecting. Can you give us an evidence in rejecting this this null hypothesis? And somebody also asking, can you give us the evidence in accepting this null hypothesis? Each statistic test is used for a different test. In t-test, no, in test statistics, sorry, you can use a C-score, T-score, the F statistics, or chi-square statistic. This will be used for the following test, no? C-test, T-test, ANOVA test, and chi-square test, respectively. No? Of course, for Z-score, that is for C-test. T-score for T-test. F statistics used for ANOVA test. And of course, chi-square used for chi-square test. We will consider three conditions in choosing an appropriate test statistics. These three are when the population variance is assumed to be known, when the population variance is assumed to be unknown, and when using the central limit theorem. Again, these three are when the population variance is assumed to be known. It means to say that given, define ang ating population variance. So when the population variance is assumed to be unknown and when using the central limit theorem. So in this condition, the Z-score is used. The formula for Z-score is given by the formula here. Okay, so this is statistics Z. Then Z is the Z-score. Mean is the sample mean, the X bar. The population mean, of course, the population standard deviation, and N is the sample size. So based on the given formula, and as what we have here, from example 2.1.1, so therefore the statistics or the Z-score is negative 0.1414. So example 2.1.2, same. So therefore this is negative 14.14. And for example 2.1.3, based on the given, of course, in this example, the Z-score is 5.48. Direct substitutions actually. Then how about the test statistics when the population variance is assumed to be unknown? So this will be the formula for that. So that is, of course, T-score. Okay, this will be the formula in getting the T-score. We have a degree of freedom is equal to n minus 1. Then where T is the T-score, this one, bar X is the sample mean. Of course, this will be the population mean and the sample standard deviation, and then is the sample size. So based on the given example 2.2.1, if we are going to substitute the given based on the formula of T-score, therefore the answer is 1.94. For 2.2.2, same as direct substitution, we could able to get the negative 6.67. And for example 2.2.3, same direct substitution, we can get the negative 0.70. Now, how about the test statistic using central limit. The central limit theorem, or the CLT, states that if a random sample of size n are dropped from a large or infinite population with infinite mean and variance, then the sampling distribution of the sample mean is approximately normally distributed with the mean and the standard deviation of this given formula. Okay? So in other words, the sampling distribution of the sample means approaches a normal distribution as a sample size gets larger. So no matter what the shape of the population distribution. So this fact holds especially true for sample sizes over 30. Again, holds especially true for sample sizes over 30. And all this is saying is that as you take more samples, especially the large one, your graph of the sample means will look more like a normal distributions. So example 3.3.1. So based on the given problem, we can get the given. Then from the given and based on the given formula here, direct substitution, no, based on the given, so we can get the CLT 101.42. Then for the test statistic Z, that is 58.33. Another example, of course, that is GMA-ABS claim that their employees had a mean monthly salary. So we can get, of course, the given based on the given problem. Then direct substitution in our formula for us to get this 365.15 for the CLT. Then for test statistics A, that is negative 37.50. Now, so after the test statistic is computed, the critical region is set. So the set of all possible values of the test statistic could range from negative infinity to positive infinity. And this will be divided into two regions. One region will be set as the acceptable region, and the other is the rejection or critical region. The division of these two regions will be based on the alternative hypothesis. So, in constructing the rejection region, it is important to correctly formulate the alternative hypothesis. So, we have here the possible alternative hypothesis in its corresponding critical region for testing population mean when the population variance is assumed to be known. So, of course, the population mean, the possible value of the population mean, and the value of test statistics, and, of course, the critical value. So, based on what we have here, we have a different symbols to be used to identify that this will be the test statistics and this will be the critical values. So, rejection, of course, example. For example, if we have a given bar X or the mean, the population, of course, and so on. So, we need to define the null and alternative hypothesis. Then, get the test statistics A. Therefore, we can get the negative 14.14. Since the critical region is less than, is use the alternative hypothesis, Z less than negative ZA will be used, no? And so on. So as what we have here, the difference between two consecutive number is 2 because of these two, no? Then this will be the say score. This will be our negative 1.645 and through 9 to 5%. Then example number 2.1.2. So we need also to define the null and alternative hypothesis. And we need to take note that we use not equal because it was indicated to test that the hypothesis that the new face mask design average profit increase is not 10%. So as what we have here, negative 14.4 and then 0.05. Therefore, the critical region is stated here. So this one is 1.645. This will be the acceptance region. This will be the critical region. This will be the rejection critical region. The difference between two consecutive number is 3 because of our X score. Example number 2.1.3, same procedure. So that is 5.48. Then the critical region, as what we have here, that is the right side, of course, that 90% acceptance region. Rejection in critical regions, that is 10%, and so on. So the rejection region with the population variance is assumed to be unknown. So this time, the population variance is assumed to be unknown. So we have here the alternative hypothesis and the critical region or regions. So example, we have null same, no? With the given, no? So therefore, the T score, no? That is 1.94. Based on the given, no? Given. Then this will be the critical region. The acceptance region is 95% and the rejection critical region is 5%. Example 2.2.2, in getting the T-score, no? So we have here defined the given with null and alternative hypothesis. Then direct substitution, we can get negative 6.67. Then the critical region, as you can see here, the rejection critical region is the 10%. And the acceptance region is 90%. For negative 1.318, no? Based on the given computations. Example 2.2.3. So we have here the given, no? The null hypothesis, that is 0.70, then not equal to 70. For this will be equal 70 for null hypothesis, and alternative hypothesis is not equal to 70. So direct substitution, so we can get negative 0.70. Then based on the given, we have the critical region here. Okay? So we can get 2.81, 86.1, this one, negative. So therefore, the acceptance region is here and the critical region over there and left and right side. Now, rejection region using central limit theorem this time. This case happens when the population is not normally distributed or approximately normally distributed and the sample size is 30 or more. Okay, so based on the given example, 3.3.1 and 3.3.2. So we have here the given of N35. The population, of course, 5,000. Then sample mean is 6,000. Standard deviation is 600. Then 0.5 ang level of significance. Direct substitution, we can get the C score 58.33. Then the critical region here, that is 1.645. So this will be at the right side. Sample 3.3.2, we have a given here already. Then we define the null hypothesis, that is 12,500, and the alternative hypothesis less than 12,500. So based on the given formula of C test or C score rather, then direct substitution, then we can get negative 37.5. Then the critical region is, of course, at the left side for negative 0.282. Now, how about the problems involving tests of hypothesis on the population mean? So this time, as what we have here, no, based on the given n is equal to 200, and so on and so forth, no? So the formulation of null hypothesis, the null hypothesis is equal to 5, and the alternative is less than 5. Okay, they specify the level of significance, that is 0.05. Select the appropriate and compute the test statistics. So using C-score, we can get negative 14.14. So therefore, we need to establish the critical regions based on the alternative hypothesis. Of course, we can get 1.64 negative actually. Then make a statistical decision. Then we can draw the appropriate conclusion. So as what we have here, the sample appropriate conclusion, there is enough evidence to conclude that the average reduction of production expenses per bottle is less than 5 pesos. For example, number 2, no, using, of course, hypothesis, significance level, test statistics, no, T-scores, no, critical region. No. Then, for example, 2.2.1, we have 1.94 is less than 1.764 is true. Therefore, the null hypothesis is rejected from the illustrated given. Then 194 lies within the critical region. So how we'll be able to conclude? There is sufficient evidence to conclude mean number of hours to finish answering the statistic module is greater than 5 hours. Example 2.2.3, we need to define, we need to give the given, to write the given first, identify the given, then hypothesis, null and alternative, significant level or significance level, then test statistics. Then we need to define the critical region using the t-distribution table. Okay, then so this will be our references: MSA Statistics and Probability, Alferez and Duro, Statistics and Probability by Bilicena, RR and others, by Rick's Bookstore, Graph Generator retrieved by, of course, Good Calculators, calculators.org, Department of Mathematics at MSU IIT, and Department of Education. And of course, this will be an additional references for this lesson. in hypothesis thing, and of course, the Department of Education, Republic of the Philippines. Thank you and God bless. Of course, the Department of Education in the Philippines. Thank you and good luck everyone.